Yeah, CMOS inverter. I'm sharing my screen. So what is this? First we'll see the CMOS inverter, and next we'll go with the CMOS voltage transfer characteristics of CMOS inverter. Okay. First, CMOS. What is CMOS? CMOS is nothing but what complementary metal oxide semiconductor. Okay. So CMOS. One second. Yes. CMOS inverter. CMOS is nothing but what complementary complementary metal oxide semiconductor. Okay, we already seen NMOS and PMOS, so that we are using which MOSFET means enhancement, NMOS, NMOS, and PMOS in CMOS. Okay, that means complementary means what PMOS has what pull up transistor, and NMOS has pull down transistor. Okay, pull down transistor. Okay, that too we are using which type of transistor means complement enhancement NMOS and PMOS. Okay, enhancement NMOS and PMOS means what like there is no channel will be there, so we need to induce the channel by applying gate source voltage. So that means for NMOS we need to apply VGS positive, and for PMOS we need to apply VGS negative. Okay. P channel MOSFET. P channel MOSFET means what? The channel is due to holes. N channel, the channel is due to electrons. Okay. That you need to remember. Basically, symbols I told you, but basically which symbols we are using means suppose this is NMOS. Okay. So this is NMOS. This symbol we are using. Okay. So if it is NMOS, this is drain, source, and next gate. Okay, we are using this one, and this is NMOS. And next PMOS, how we are using this is this is PMOS given through the bubble. So here you have drain. Okay, you have drain, source, and gate. Okay, one second. Wait a minute. Yeah, this is PMOS. Okay, so next if you see the basic inverter, so how the basic inverter will look like. So basic inverter. Mm, So we have this is the basic inverter. So we are going to design this basic inverter by using the CMOS. Okay. So here y equal to what you are getting a bar. Okay, y equal to a bar, and this is input and this is output. Input and output. Okay. So before saying this, so how to draw this CMOS? So this is VDD. This is VDD, and next pull up transistor as a PMOS, pull up transistor as PMOS, and pull down transistor as NMOS, pull down transistor as NMOS. These two are connected like this. Okay, here you are giving A as input, and you are getting the output y equal to what A bar. So this is output. Okay, so if you give the terminals here for PMOS, source is connected to drain. Okay, so source is connected to VDD, and this is gate is common, and here this is drain. This is PMOS. This is PMOS. Again drain, here drain, and the gate, and this is source. This you can call as what? This you can call as VSS, or we can call as ground also. Okay, so we are connecting to ground. This is connecting to ground. Okay, so like this we'll connect. Okay, so I need to know about for PMOS. For PMOS, what are the ideal characteristics? Okay, for PMOS. For PMOS, if input is zero, okay, if input is zero, uh, so that means source to drain will be act as what short circuit. These are the ideal characteristics. Okay, if input is one, okay, source to drain, source to drain will act as what open circuit. Okay, this is for this is for PMOS. Okay, for NMOS, for NMOS, okay, for NMOS, if input is zero, drain to source, drain to source is acting as what open circuit. Okay, and if input equal to one, okay, if input equal to one, what happens? Hmm, drain to source will act as short circuit. Short circuit. Okay. So from this, I can draw the diagram, the basic diagram. So how to draw the basic diagram? Combining this NMOS and PMOS, how I can draw? So here input A. Let us take input A and PMOS, and next NMOS, and output Y. Output Y. Okay. So here if you see, so that means if it is zero, from this we can say that what is PMOS? PMOS, if input is zero, this is acting as short circuit, and NMOS is acting as what open circuit. Okay, so that means you are getting what VDD. VDD means what one you are getting. Okay, and if it is one, if it is one, so PMOS is acting as what open circuit, and NMOS is acting as short circuit. Okay, so that means this is connected to what ground. So ground means what it is zero. Okay, so when you are when you are connecting zero, you are getting logic one. When you are connecting input connecting logic one, you are getting logic zero. So the inverter is satisfied, no? So the inverter is satisfied. Okay. So from the diagram also you can verify. So here you see. So just I am giving zero with related to circuit. I am verified. Okay. So with related circuit I am verified. Okay. One second. Okay. So here, if you see the with the diagram, so how to implement with this diagram? So first, I'm giving input zero. So input zero means what? Here, this one will be PMOS will be short circuit and NMOS will be open circuit. Okay. Here you are giving input 0. So you are giving input 0 means this is VDD and this is ground. Okay. So ground. So that means output is connected to VDD. So you are getting output equal to what? VDD. VDD is nothing but a logic one. Okay. And when input is what? Input is 1, we'll see. So when input is 1, what happens? PMOS will be open circuit. PMOS will be open circuit and NMOS will be short circuit, and this is connected to ground. Okay. Here you are giving 1 as input. You are getting the output. That means the ground is connected to output. Ground is connected to output. So that means you are getting 0. Okay, it is satisfying the operation of inverter, no? So we already seen in the digital electronics, digital design. That means you are giving 0 means you are getting 1, and you are giving 1 means you are getting 0. Okay, so this is the basic operation of CMOS inverter. Okay, now we'll see the CMOS inverter voltage transfer characteristics. Okay, so what is this CMOS inverter voltage transfer characteristic? We'll see. Okay. So this is a very important topic. Okay. They can ask in the interview also questions related to the CMOS inverter voltage transfer characteristics. Okay. Uh, so CMOS inverter voltage transfer characteristics. Voltage transfer characteristics. So what are these voltage transfer characteristics? First you draw the basic CMOS circuit. Okay. So first you draw the basic CMOS circuit. So this is PMOS, NMOS, ground. This is VDD, ground, and here this is PMOS, and this is NMOS. These two are connected, and here you are giving input V in, and here you are getting output V out. Okay, so here if you see, this is nothing but what? This is source, gate, and drain. Okay, this is what? Drain, gate, and source. Okay, so this is PMOS and this one is NMOS. PMOS and NMOS. Okay, so if you see here, that means here what is this? This is nothing but what we can consider. This is the VGSP. VGSP. Okay, gate to source voltage of PMOS. Okay, and next if you consider this one, VGSN. Okay, VGSN. VGSN is nothing but gate to source voltage or NMOS. Okay, and if you consider this one, this is VDSP. VDSP. So VDSP is nothing but gate to source, drain to source voltage of PMOS. And if you consider this one, drain to source voltage of NMOS. Drain to source voltage of NMOS. Okay. So here you need to consider some parameters. That means we already seen VTN. VTN is nothing but what? VTN is nothing but threshold voltage of threshold voltage of NMOS. Okay. So what is the threshold voltage of NMOS? We already seen the MOSFET. No? VTN. VTN threshold voltage of NMOS is what positive we are giving. Okay. There we already seen. Okay, like minimum gate voltage such a way that VGS should be greater than VT, so that channel is forming, that is nothing but strong inversion layer. Okay, so when the channel is forming, after that when you are varying VDS only, there is a drain current, and we already seen some regions of operations like cutoff region, linear region, non-linear region, saturation region, and channel pinch off condition, channel pinch punch through or reach through. Okay, there the current become constant. That we have seen the operation related to the NMOS and PMOS. Okay. So for PMOS, what happens? VTP, threshold voltage, that is equal to what? Negative. Negative. Okay. And next, VGSN. Okay, VGSN. VGSN, what I can write? I can write as the potential difference between VG and gate and source. Okay, VGSN equal to what? Potential difference between gate and source. Okay, this gate and source. I can write as Vg minus Vsn. Vg minus Vsn. Okay. So this is equal to what? Vgsn equal to means you are applying the input voltage with respect to ground. Ground is anyway 0 volts. So I can write as from here we can say that Vg equal to Vin. That means Vin minus ground is 0. Okay. That means here with respect to n means you are getting V in only. Okay. So from here I can write as VGSN equal to what? V in only. Okay. Understood? So VGSN equal to V in only. And next VGSP. VGSP. So VGSP equal to what I can write? Vg minus Vs with respect to P side, with respect to P side. So that means from here, we know that Vg equal to what? Vg is connected to V in. No? So that means V in minus Vs is connected to VDD. Vs is connected to VDD. I can consider Vs as what? VDD. Okay. So Vs minus VDD. Okay. So Vs minus VDD. That is VGSP. VGSP. What I can write? VGSP equal to what you got? V in minus VDD. V in minus VDD. Okay. So this is VGSP. And next, sorry, this is VGSP. You got no? Okay, VGSP. I'm calculating VGSN and VGSP. Next, I will calculate what VDSN. Okay, VDSN. Okay, so VDSN equal to what? VDSN equal to VD minus VS. VD minus Vs with respect to N. Okay. So here you can write this is for what? NMOS, NMOS, PMOS. Okay. And this is NMOS and this is PMOS. Okay. Next I am drawing for NMOS. Okay. NMOS. Okay. So here VD equal to what? VD equal to VDSN. Okay. VD equal to, mm, 1 second. See here. So VD equal to what? V out only. So VD equal to V out only. V out only minus Vs equal to what? Connected to ground. So this is 0 only. So that means this is equal to V out. V out. Okay. So from here I can say that VDSN equal to what? V out all get. V out. VDSN equal to V out. Okay. And next for PMOS you see. For PMOS, for PMOS, uh, so VDSP. VDSP equal to what? VD minus Vs with respect to P. Okay, that is PMOS, no? So VD equal to what? Here, see here. VD equal to VD equal to V out, no? VD is connected to V out. Okay, VD equal to V out minus Vs equal to what? VDD. Vs equal to VDD. So from here, I can write what I can write here. So here, yes, this is equal to what? VDSP equal to. So VDSP equal to V out minus VDD. V out minus VDD. Okay. So so what you got? So I'm writing separately. Uh, so first VGSN. VGSN equal to what? VGSN equal to V in you got. Okay. And next VDSN for NMOS I'm writing. VDSN equal to what you got? V out you got. And next for PMOS, this is for NMOS. Okay. This is for NMOS. And for PMOS, okay, VGSP, VGSP equal to what you got? A V in minus VDD, VDSP equal to what? VDSP equal to V out minus VD. Okay, so this is for what? NMOS, PMOS. This is for PMOS. Okay, and next for separately, if you write the region of operations, just you are combining both the operations of NMOS and PMOS. That's it. Okay, so here if you see, uh, so for NMOS, okay, NMOS for NMOS, yes, for NMOS, if you see NMOS, if VGSN is less than VTN, then NMOS is operated in which region? Cutoff region. Okay, and when VGSN is greater than VTN, then it is operated in linear or saturation region. Saturation region. Okay, and so again, when VGS is greater than VTN, you need to check for two conditions. What are those conditions? That means it is depending on what, like we already seen, no, VDSN should be less than VGSN minus VTN. Okay, that means this equation I can write like this also. What is that equation? VGSN minus VTN should be greater than VDSN. Okay, during the operation I told you with this equation. So both interchanging, you write this condition also. Okay, they both are same only. Okay, and what is this is what linear region, linear region. And what is nonlinear saturation region? VGSN minus VTN should be greater than VDSN. So this I can write as what? VGSN minus VTN should be less than VDSN. This is saturation region. Saturation region. Okay. This is for NMOS. Okay. Similarly for PMOS, if you write, so what you will get for PMOS if you write, so for PMOS I'm writing just reverse, no. So PMOS, we are applying positive voltage with respect to NMOS and negative voltage with respect to PMOS. Okay. Uh, so just reverse, no. So VGSP should be greater than VTP. Then this is cutoff region, and VGSP is less than VTP. Then which is which region? Linear region, linear, or it can be saturation region. It can be operated as linear or saturation. Linear or saturation decides what this value. That means we already seen that like VGSN, VGSN, VGSN. When VDSP, we already seen. No? So one second. When VDSP, when VDSP is greater than VGSN minus VTP, VGSP minus VTP, then which region? Linear region, no? So this you can write as VGSP, VGSP minus VTP is greater than VGSP. Okay, this is which region? Linear region. Okay, and next saturation region, when VDSP is less than VGSP minus VTP. So this I can write as what? VGSP minus VTP is less than, one second. Mm, okay, here less than you will get. Linear region means what? Just here less than you will get. Here greater than you will get. Here greater than VGSP, then which region? Saturation region. Okay, saturation region. These conditions I am going to use in the VTC equation. Okay, VTC equation. Till here, is it fine? Any doubt in this? Your response.
No, sir.
Okay. Next you see. Next, I'm drawing the voltage transfer characteristics. Okay. So I'm drawing the voltage transfer characteristics of this by using uh, this one. Okay. Mm, these conditions. So this is V out and this one is V in. This one is V in. Okay. So now you see. So that means here you have here 0 is there. Okay. And VDD by 2 half. Okay. And next here VDD. Okay. Next in the x-axis, let us take you can take the negative value also. Why? Because for the PMOS you will get the negative values. Okay. So that's why you need to take the negative values also. So PMOS we already seen whatever the characteristics are there, we are giving the negative value. So ID current is negative and uh, this VGS, VDS you are applying negative. So that means you are getting in third quadrant. So all are negative only. Okay. So if you observe here, so this is 0 and next this one is let us take VTN and here this is VDD by 2 VDD by 2 and here VDD plus VTP VDD plus VTP and here we can consider as VDD. Okay, this is VDD maximum value. This is maximum value. Okay, now you see. So that means when like uh, so during this VDD, during this higher value, okay, higher value, PMOS will be which region and NMOS will be which region? PMOS and NMOS. Okay. So PMOS and NMOS. Okay. So when means you are applying a smaller amount of voltage, so that means when V input this is nothing but what V input equal to 0. Okay. So we already seen when V input so that means V input equal to 0. What we are seeing V input equal to 0. Yeah. So V input equal to 0 means so PMOS will be in linear region. Okay. So when you are giving 0, PMOS will be on. No? This table we already seen. So that means short circuit. Okay. PMOS will be short circuit and NMOS will be open circuit. From this, I can conclude that when V in equal to 0, so PMOS will be which region? PMOS will be in linear region. PMOS will be in linear region and NMOS will be in cutoff region. NMOS will be cutoff region. Okay. And from here to here, tell me, you have two complementary transistors, no? PMOS, okay, and next NMOS. PMOS will be which region and NMOS will be which region? PMOS will be which region? You are giving maximum voltage, okay? Maximum voltage means maximum means you are giving maximum one. Okay, when you are giving one, what happens? PMOS will be open circuit and NMOS will be short circuit. So that means in this region, what happens? PMOS will be in a cutoff region. PMOS will be open circuit. That means cutoff region, and NMOS will be linear region. That means that will be on. Okay, that will be short circuited. Okay, that will be on. And next, so if you draw the curve, okay, like this, okay, so gradually, so if you combine like this, okay, if you combine like this, so what happens here? Here what happens? So one second. So here PMOS will be so going into where, so PMOS is so when it is PMOS voltage is decreasing. Okay, PMOS voltage is decreasing. So that means if you combine these this one, and also this is VTN. Okay, so from these conditions, okay, from these conditions, VTN and VTN and VTP decides whether the given region is linear region or saturation region. We already seen, no? So when VGS is greater than VTN, then it is operating in linear region or saturation region for NMOS. Okay, and when VGSN is less than, okay, input voltage only. So that means input voltage into we are applying. So you got VGSP equal to what? Vin minus VDD, and VGSN equal to input voltage. Okay, so that means VGSN will decide whether the given transistor is operating in either linear region or saturation region. Okay, so that means what happens if you see here when PMOS, here PMOS is cutoff region, so it is going lower value. Okay, lower value. So what happens? PMOS will be what? PMOS will be, so PMOS will be operated here. PMOS will be operated in linear region. PMOS will be operated in linear region, and in this PMOS will be operated in saturation region. PMOS will be operated in saturation region. Okay, so in this case, what happens? NMOS. Okay, NMOS, if you are giving maximum value, so what happens when it is going maximum value? NMOS will be operating in which region? NMOS will be operating in linear region. And next, here in this curve in between this, so here NMOS will be operating in saturation region. Okay, so from this I can conclude conditions. Okay, so when this is a linear region and when this is saturation region, we'll see. So PMOS will be in what? PMOS will be in linear region, no? So PMOS will be linear region means what? When VGSP, PMOS will be in linear region when we, so this condition is what? When VGSP minus VTP is what? Less than VDSP is the condition when the PMOS in linear region. And next, NMOS in linear region, what is the condition? When VGSN, VGSN minus VTN is what? Greater than VDSN. Okay, this is the condition. And PMOS in saturation. What is the condition for saturation? PMOS. So PMOS saturation VGSP minus VTP is greater than VDSP. And NMOS in saturation. What is the NMOS in saturation? VGSN minus VTP is less than VTN. Less than VTN. Okay, this is in saturation. So from this I can conclude that that means when input voltage is zero. How much of output voltage you are getting? VDD. Okay, VDD. VDD is nothing but basically if you consider 5 volts. Okay, so this is nothing but in digital we call as what? Logic 1. When you are giving logic 0, you are getting what? Logic 1. Okay, next, input voltage is VDD. Okay, input voltage is input voltage is VDD. Okay, so that means when you are giving input voltage, that is VDD. VDD is nothing but what? Logic 1. Okay, logic 1. What you are getting the output voltage? So this is input voltage. Okay, this is also input voltage. Okay, input voltage. And in the x-axis, this is what? Output voltage. If you see the output voltage you are getting 0. 0 means what? Logic 0. Logic 0. So from this characteristics, it is satisfying the characteristics of inverter. So what is the inverter? We already seen the truth table. So here you are A, Y equal to what? A bar. Y equal to A bar. That means you are giving 0 as input. Okay, let us check this input voltage and output voltage. When you are giving 0, what you are getting? 1. Okay, so that means 0 means what? You are getting VDD. Okay, and when you are giving 1, that means what? When you are giving VDD, you are getting 0. You are getting 0. So that means 0 means logic 0 only. So that means it is acting as a inverter. It is acting as a inverter. Okay, is it fine? Do you understood? Any doubt in this?
Yes, sir.
So from here, one second. From here, I can say that. Okay. Hmm. From here, I will tell you. Here. Okay. So here, uh, VGSN minus VGSN minus VTN is what? Less than VDSN, no? Less than VDSN. This is the condition for what? Saturation. I am trying to calculate the condition for saturation. Okay. So here, if you see the saturation, that means that is only the saturation, no? For which one? For NMOS, I am calculating. Okay. For NMOS, what is saturation? VGSN minus VTN. Okay. This one. Okay. This one. This is the condition. Okay. VGSN minus VTN is less than VDSN. Okay. From here, what is VGS? What is VGSN? Where you got here? VGSN equal to V input minus minus VTN. VDSN equal to what? V out, no? From for NMOS, VGSN equal to V in and VDSN equal to V out. Okay, that I am going to substitute here. Okay, so if you substitute, what happens? What you will get? V in minus VTN is less than V out. Okay, so that means this condition only, no? So V in minus VTN. This is the range. This is the range. What is the range? This is nothing but this condition is nothing but V in minus VTN. Okay, V in minus VTN. Okay, so this is the condition V in minus VTN. What happens? Less than V out only. Then this is in which region? Saturation region. This is for what? NMOS. NMOS is operating in which region? Saturation region. Okay. And next, for PMOS you see. PMOS, okay, I'll change the color. Okay, for this one, I will use. Okay. VGSP minus VTP is greater than VGSP. Okay. This is the condition, no? We already seen. See here, where you seen for PMOS, when it is in saturation, VGSP minus VTP is greater than VGSP. Okay, so this is the condition. Now, for this one, by seeing this diagram, I came across for PMOS. Okay, PMOS, VGSP equal to what? V in minus VDD, and VDSP equal to V out minus VDD. Okay, these conditions I'm going to substitute. Okay, so VGSP equal to V in minus VDD and VDSP equal to V out minus VDD. Okay, so if you see here, if I substitute, what I will get, I will see. So VGSP equal to what? VGSP equal to V in minus VDD minus VTP is greater than VDSP. This is VDSP. Sorry, this is VDSP, not VGSP. This is VDSP. Okay, VDSP. Okay, VDSP. What is VDSP? V out minus VDD. V out minus VDD. So here both will cancel now. VDD minus VDD get cancelled. So what you are getting? V in minus VTP is greater than V out. V in minus VTP is greater than V out. Okay. So that means V in minus VTP. So V in minus VTP means what? This range only. Okay. This range only you will get. Okay. This is nothing but V in minus VTP. V in minus VTP is greater than V out. Okay. V out. Okay. So you'll get this during this one. PMOS will be in saturation. Okay. I got the condition also. So this condition that means NMOS will be saturation. So this is the condition when NMOS is in saturation. What is the condition? V in minus VTN is less than V out. Okay. So this is the condition. V in minus VTN, V in minus VTN is less than V out. Okay. And this is also condition. So this is also condition I got. V in minus VTP is greater than V out. Okay, is greater than V out. Okay, so this is about today's session. 1 second.